Okay, so alpha helices are a type of secondary structure in protein. What is the length of a 43 kilodalton single-stranded alpha helix protein segment? This is important because the single-stranded alpha helix protein means that it's not wrapping in on itself, right? We just have the alpha helix to think about. So assume a mean residue mass of 110 DA, which is Dalton. Okay. Okay. So are these different numbers than yours, by the way? Cool. I hate putting these up and they have, the exact answer, because then I get a bunch of people that don't do them. We want the length, and that's alpha in angstroms in this case. Okay. So the first thing we need to do is, well, we have this 43 kilodalton. We need to get that into residues. Okay. So that's important because we actually were given a number for what the conversion between daltons and residue would be. And so we have the 43 kilodalton. Well, it's in kilo, right? So we got to get that out of kilo into daltons. So that's 1,000 daltons for 1 kilodalton. So there's 43,000. And then we have that number. One residue is 110 dalton on average. And so our average number of residues here is 391. Okay.
And that was just pulled from
That was the stuff they gave us, actually. Yeah. So they gave us the kilodalton, and they gave 110 daltons here. And I just used that to figure out the number of residues then. And the important part is the residues are going to give you how many, R groups are there, right? How many individual amino acids we're working with, okay? Dalton is a mass measurement, if you're curious. So we have 391 residues. If you remember the periodicity we talked about for the alpha helix, this is related information, and it's in that same part of the book, okay? If I remember correctly, it's just one page within one page. Very close. So a single turn of the helix, so our repeating units of the helix, is going to be 5.4 angstroms along. There are 3.6 residues per turn. Remember the periodicity? So every turn has 3.6 residues, 3.6 amino acids. And one turn is going to be 5.4 angstroms in length. They're averages, actually. But yeah, kind of. Remember, this is biology, so everything's messy. Yeah. There's not a lot of really nice, beautiful constants that aren't, don't have much air. All right. So the rise per residue would actually be 1.5 angstroms, if you're curious. And that's just taking these two numbers here. 5.4 divided by 3.6 would give you your 1.5 angstrom per residue rise. You could just use both numbers together, but, simplify. Okay, so we have a segment length of 391 residues times our 1.5 angstrom per residue, right? And then that would give us our 586 angstroms, which would be the answer to this one. Does that make sense?
You go over again.
Okay, so residues will be the number of amino acids, essentially, we have in this segment, right? And so they're in an alpha helix. That alpha helix winds so that every 3.6 residues, it repeats. So you'd be on the same segment side, okay? That essentially tells you how many corkscrews there are, right? Okay. Remember, we're measuring length. So that actually gives you length right there, but we're measuring that, and right now we're measuring in corkscrews, right? Loops, or periodicity. Okay. So we need to get that in angstroms. So again, if you look in your book, you'll see that there's an average length for that periodicity of 5.4 angstroms. So if you loop the alpha helix, it comes back to the same point and overlaps every 5.4 angstroms. Okay? Okay. Now you can actually take that number if you want. And so right here we have residues per turn, right? This is angstroms per turn. And you could just use that to solve through. So we have 391 residues. We have time divided by 3.6 residues per turn, right? And that gives you number of turns. And then we have 5.4 angstroms per turn. Multiply that, and we would get the answer.
Did they just simplify?
Yeah.
Angstroms over residues?
Yeah.
That's
Yeah. And that's entirely valid too. If you want to do less calculator work all in one go, you can take this number right here, divide it by that number, turns cancel, and we get angstroms per residue, right? That makes sense? Everything good?